Hi there. This video is going to be some extra examples to go with what we were talking about in the video with the PowerPoint for lesson 6-2 inverse functions and relations. So I want to highlight a couple of things and do a couple more examples just to make sure that you're understanding everything that we need to be doing. And I know you like to write some stuff down sometimes. So I mentioned in the other video that sometimes you're going to see ordered pairs and the relation to tell if it's inverse or not, do X and Y just flip-flop spots? Well, what if you just have it in a, whoopsies. What if you have it in a chart? Sorry about that. Do that. So what if you have it in a chart? You've got a chart that looks like this. So you got X and f of X. And you've got 1, 2, 3, 4, 12, 16, 20, 24. Something like that. That's your chart. Now I could ask you what is, so if I could say what is f inverse of 12, and you'd say it is 1 because f of 1 is 12. If f of 4 is 24, what's f inverse of 24? It's going to be 4. So they just pair up that way again. You can look at them that way and just instead of, so the inverse function value is always going to be what's over in the right-hand column or the bottom row, depending on how your chart is set up. And the answer is what it pairs with in the left-hand column. So just an FYI that's there. Now, where I want to spend the majority of my time is taking functions and finding their inverses. So we have that process figured out for ourselves. So what we're going to do is, remember step 1 is to make f of x moves to y, then swap x and y. 3 is solve for y. And 4 then is y becomes f inverse of x. And hopefully you caught in the other video, all this is, this notation just means inverse. That's all it means. It doesn't, the -1 doesn't have any other kind of value at this point. It's strictly notational here. So let's find the inverse of a function. Let's find the inverse of 5, x minus 3 over 5. F of x equals x minus 3 over 5. So step 1, f of x becomes y. Y equals x minus 3 over 5. That's step 1. Step 2, swap x and y. So we have x equals y minus 3 over 5. Step 3 is solving for y. So we're going to multiply both sides by 5. 5x equals y minus 3. Add 3. 5x plus 3 equals y. So this process here was step 3. And lastly, step 4, y becomes f inverse of x. And we always write that first, so we'll just use the symmetric property and flip it around. F inverse of x is 5x plus 3. That's step 4. So your problem solving can be that quick and that simple. Is it always going to be quite that fast? Maybe not, but it can be. All right, let's do another one. Erase this one. And now we're going to say, let's find the inverse of, let's do f of x equals x plus 1 squared plus 3 plus 3. So step 1, f of x out, y in. Okay, swap x and y. That's step 2. X equals y plus 1, that quantity squared, plus 3. Solve for y. I'm going to subtract 3 from both sides. X minus 3, y plus 1 quantity squared. All right, how are we going to cancel out the squared? That's right, we got a square root. So now we have square root of x minus 3 equals y plus 1. And we're going to subtract 1 from both sides. Now write this carefully. X minus 3 is under the radical, minus 1 is not. Some people like to write it this way. Other people prefer to write it this way. Negative 1 plus square root of x minus 3 equals y. Either one is fine. I don't care. Mostly, I just don't want you to end up accidentally putting that negative 1 under the radical. Okay? And then the last step, y goes out, f inverse of x comes in. Since I think you will most typically see it written that way, I'll leave it that way. So that is what you are doing with figuring out if something is an inverse, or turning something into its inverse. Now, last thing is, let's determine whether a pair of functions are inverses or not. So remember, that means if we're going to do that, we have to compose them. If f of g of x equals x and g of f of x equals x, then we have inverses. So, let me see, let's grab 2 functions. 2x plus 3. F of x equals 2x plus 3, and call it g of x, sorry. G of x equals 2x minus 3. Are they inverses? So first we need to do f of g of x, which means we're going to take g of x, 2x minus 3, and plug it into f of x. So we're going to do f of 2x minus 3, which means we're going to go 2 times 2x minus 3 plus 3. Now notice there's parentheses, so you got to distribute. 4x minus 6 plus 3. Simplify it, always simplify it as far as you can. 4x minus 3. That didn't simplify to the identity. Because that happened, you can just stop right now and say not inverses. Don't even keep going. It doesn't matter. It has to work both ways. So if it doesn't work one way, you're done. Okay, let's try another one. Let's try our f of x. Let's see. Our f of x equals 1/3 x squared plus 1, and the square root of 3x minus 3. Are those 2 inverses? Well, let's see. Let's take g of x and plug it into f. F of the square root of 3x minus 3. So 1/3 times 3x minus 3 quantity squared plus 1. Well, what are our power and root going to do? They're going to cancel. Oh, thank goodness. So now we're left with 1/3 times 3x minus 3 plus 1. Distribute your 1/3. So you have x minus 1 plus 1, which equals x. Hey, it worked! F of g of x is equals x. It's the identity. Now let's go the other way. Let's plug f into g. So we'll say g of 1/3 x squared plus 1. Well, this should be interesting. Square root of 3 times 1/3 x squared plus 1 minus 3. All of that's under the square root. Remember, square roots can act like grouping symbols. So let's take care of everything underneath the radical first. Distribute the 3. So we got x squared plus 3 minus 3. Oh, this is looking promising. Cancels out. The 3's cancel. Square root of x squared equals x. Now, you might be saying, well, shouldn't it be plus or minus? In this case, no, because we're strictly simplifying, and we are looking just for the identity here. We're not specifically solving. So these are inverses. So that is the type of stuff that you're going to be doing today as you practice in your homework. So review these videos, review these examples to help you out, and happy practicing.